I'm very glad to be here to introduce our work multi-aspect diffusion network inference. In this work, we have investigated the problem of inferring multi-aspect diffusion network without infection time steps, but using only the final infection status of nodes. Diffusion network is a directed graph that represents the diffusion relations between nodes. The nodes here are usually people and users depending on the application scenario. Here are some examples what diffusion network can represent. Epidemic spread out network, social network on multiple platforms like Facebook, they all can be called diffusion networks simply because something diffuse following a network model. Diffusion network could help us clearly understand the dynamics occur on the network, and the potential usage of diffusion network is to help us make predictions, promote, or even prevent future diffusion events on the network. Since diffusion networks are so useful, we aim at recovering the diffusion network structure given the historical diffusion records. While there are many existing approaches aiming to solve this issue, they mostly based on the temporal information of the diffusion results. However, generally speaking, obtaining this information can be really expensive and sometimes misleading. Additionally, most of the existing methods assume that the diffusion network is one-aspect network, saying that the type of influence relationships in the network is homogeneous. However, because of the difference of propagation median, the type of influence relationships may be heterogeneous. For example, certain diseases can cause infections with similar symptoms, but they spread among humans through different types of media. So in this work, we proposed a method to learn the structure of multi-aspect diffusion network with only the infection status of nodes. What we want is to infer the topology of each aspect of the overall multi-aspect network based only on the final infection status of nodes. Inferring the network topology means we are inferring the edges in the network. We proposed a method called LMDN to solve this problem in an iterative way. Extensive experiments results on both synthetic and real-world networks verify our proposed algorithm.